Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad bin Haikal bin Muhammad Razali. My matric number is B0920100084. My group member is Shiva AL Rajan and Muhammad Haikal bin Abdul Wahab. Today we are going to explain about Lab 2, concept of water saturation line. We are from section BMMV S2/1. Our lecturer is Professor MADYA TS Dr. Muhammad ZAHIR bin HASSAN. For the procedure, as the apparatus setup, check that the calorimeter valve and the drain valve at the base of the boiler are both closed. Check that the main power of the console is switched off before filling the boiler. Open the filling point at the top using the key provided. Fill the equipment using purified or deionized water until the water level is halfway up the side glass at the front of the boiler. Seal the filling tube after filling with the key. For the procedure for the experiment, switch on the heater and the water heater control to maximum. Observe the appearance of the fluid in the boiler through the side glass. As the temperature increases, sketch the fluid appearance in table 1 below. Note the pressure inside the vessel as indicated by the pressure sensor P1 and the resistance indicated by the platinum resistant thermometer RM1 T1. Record the actual temperature when the absolute pressure reaches a value as in table 2. Open the throttle valve about 10 degrees. Allow little flow of steam for 2 to 3 minutes. Then only take the temperature reading T2 after the throttle valve. Lastly, fill in the table 3. Next, for the work process, first of all, we make sure that the filling valve and throttle valve are really closed. Make sure it closes tightly. Next, we power on the switch and then set the heating power to the maximum. Next, we took the reading from steam pressure and the pressure read was bar 1 to bar 4. The reading was taken as T1 and T2 by switching the thermometer switch. As we record T1 for each pressure, we also observe the fluid appearance for the side glass and sketch it. When the pressure reached 4 bar, we took the T1 reading first and then we get the second reading for the T2. We open up the throttle valve to let the steam out and then we will get the reading of T2.
Alright, now we'll look into the disciplines of the lab. Okay, first of all, before doing the experiment, we were ensured to wear the lab coat and safety shoes. Then we were also briefed about the safety do's and don'ts of the lab session by our lecturer and the lab assistant. And if there were any accidents or damages to equipment, we need to inform the lecturer immediately. Next, we always ask permission from the lecturer and lab assistant if we needed to use any of the lab equipments or apparatuses. And then we should also obey the rules of the lab session and do not play in the lab session during the lab session. And finally, once completed and leaving the lab, we need to make sure we turned off every power source of the machine we used for the experiment or for our lab session. My name is Shiva Rajan and my matrix number is B0920100467. Today I'm here to explain about our Lab 2 thermodynamics, which is concept of water saturation line. Okay, now I'll explain about the table 1. Okay, for table 1, we calculated the temperature T1 in degrees Celsius, the gauge pressure P1 in bar, and the fluid appearance. Okay, when the temperature was below than 55 degrees Celsius and the pressure was 0 to 0.5 bar, there were no any changes in the fluid appearance. And then when the temperature was around 56 degrees Celsius to 99 degrees Celsius and the gauge pressure remained same, which is 0 to 0.5, we can see there were some air bubbles forming around the plate. And when the temperature is above 100 degrees Celsius and the gauge pressure remains same, which is 0 to 0.5, we can see the air bubbles and water vapor forming around the fluid. Okay, next we'll look into the table 2. Okay, for table 2, we use gauge pressure, absolute pressure, and to find the actual temperature, which is T1. So when the gauge pressure is 0 and the absolute pressure is 1, we got the temperature of 18 degrees Celsius. And then when the gauge pressure is 1 and absolute pressure is 2, the actual temperature is 19.1. Next, when the gauge pressure is 2 and absolute pressure is 3, we got the temperature of 20.1 degrees Celsius. Next, when the gauge pressure is 3 and absolute pressure is 4, we got the actual temperature as 26.5 degrees Celsius. Finally, when the gauge pressure is 4 and the absolute pressure is 5, we got the actual temperature of 33.8 degrees Celsius. Okay, now we'll look into the table 3. When the pressure at the gauge steam pressure reaches 4 bar, we first calculated the T1 and then turned the throttle and measured the temperature too. So when the pressure was at 4 bar, we got T1 as 33.8 degrees Celsius and T2 as 19.5 degrees Celsius. Next, I'll pass to my friend to explain about the discussions for this lab. That's all from me. Thank you.
Discussion: Graph absolute pressure versus actual temperature T1. When we plotted the graph of absolute pressure against actual temperature, the result is curve where when the temperature increases, the absolute pressure also increases. Quality of steam based on TS diagram. Steam quality is proportion of saturated steam in saturated mixture. Steam quality of 0 is 100% liquid, while a steam quality of 100 indicates 100% steam or gas. To find the quality of steam X, we plot T1 and T2 of gauge pressure at 4 bar in the TS water diagram and found the value of steam X. The parameters of measurement needed to find steam quality are temperature, T1 and T2, pressure, and entrained liquid content. Saturated steam is completely gaseous and does not contain liquid. Conclusion: As a conclusion from this experiment, this lab ensures us to understand the water saturation line concept. We learned that the link between water evaporation and temperature. We also successfully did the experiment from the guidance of lecturer and lab assistant and completed the tables. We can also conclude that when the absolute pressure increases, the temperature also will increase based on the graph of absolute pressure versus actual temperature. We also able to see the appearance of fluid change as pressure increase.